Hey guys, I just wanted to make a quick video about finding the matrix of a linear transformation. Um, you can see it's already kind of written out already. Sorry about that. So it's because my phone overheated the last time I was making this video. So I'll try and indicate as we go along where we are. So we have to find the matrix of some linear transformation. The one I chose was a linear transformation from R3 to R2. It sends x, y, z to the vector whose first coordinate is x plus y and whose second coordinate is y plus 2z. Okay, and the bases I chose the bases for R3. Just arbitrarily, I just chose it to be first vector half 1 0, second vector 0 1 0, third vector 1 1 negative 1, and my basis for R2 I chose to be a half, and then second vector negative a half. And we are supposed to find the matrix of T relative to B, the basis B for the domain and B prime for the codomain. Okay, so what is involved? Well, we have to plug in each vector of the basis B into T, and then for each time we do that, we have to find the coordinates of that vector in terms of the basis B prime. Okay, so for example, if we plug in a half 1 0 into T, we get the vector 3 halves 1, and we have to write that in terms of the two vectors a half, and negative a half. Okay, so we have to solve a times a half plus b times negative a half equals 3 halves 1. And the solution, AB, that'll be the first column of the matrix of T. And we keep on going. So T of the second basis vector, we have to find that. So T of the second basis vector is 1, 1. We have to write that in terms of the basis. For R2, which is a half, negative a half. And T of 1 1 negative 1 is 2 negative 1, and we have to write that in terms of the basis. Okay, so one thing to do would be to solve each of these systems of equations. The first system gives you the first column, second system gives you the second column of T, third system gives you the third column of the matrix of T. But these three different systems of equations have the same coefficients on the left hand side. So let's collect all those together on the left hand side and give each right hand side its own column, right? So in that way we can solve all three systems at once because we're doing the same thing to each left hand side. So we start off with in the end, this column is going to tell us about the solution for C and D. Oh, there should be a D. Right? So this second column is going to correspond to the second column of the matrix of T. So let's start out by there's so many ways to go, but you could do row 2 minus row 1, get rid of this 1 half. Okay. So what happens? We get my new row 2 is 0 1, 1 minus 3 halves, we get negative a half. 1 minus 1 is 0, negative 1 minus 2 is negative 3. Okay, now for the next step we could do maybe row 1 plus a half row 2. Okay, so row 1 plus a half row 2, this plus a half this gives me 5/4, this plus a half this gives me 1, this plus a half this gives me 1/2. And now I just want to make this into a leading 1, so I multiply by 2, row 1 times 2, and I get 1 0 5 halves, 2 1 0 1 negative a half 0 negative 3. And now, as I said before, this first column gives me this. So if I look at this part, that tells me that A equals 5 halves, B equals negative a half. and A and B were corresponding to the first column of the matrix of T. So the first column of this right-hand side is the first column of the matrix of T. The second column is the second column of the matrix of T. Third column is the third column of the matrix of T. This is just the matrix of T relative to B and B prime. Okay, so that's the end. Thank you for watching. I'll talk to you guys later.